All right, let's look at another important concept in the Go programming language, and that is channels. And channels are unique to Go, or at least as far as I know. I've never seen them anywhere else. And channels are not that difficult, but they are incredibly useful. They are a means of sending information from one part of your program to another part of your program very easily. So we've seen things. What I have here is an empty package. And our empty program. I have two packages in it, same as we did last time. I have helpers, which is empty, it has nothing, and I have my main package, which just has an empty main function. Now we've seen how to pass things around before. For example, I can say func print text, and it takes a string as an argument, and it returns nothing. And all it does is log.println, and then the string that I've passed it, and then I can call that function from up here. So I could say print text hi. So what I'm doing is passing information from my main function to my print text function, and that's one way of passing information. We also saw how you could do it using pointers, and I'm not going to go through that again. You can just watch that lecture again if you wish to. Well, there's a third way of doing it, and that way is creating a channel. So I'm going to get rid of this function, and I'm going to get rid of this call to that function. And we're back to an empty main routine, or main function. So now I'm going to create a channel. And you create channels in a way that's very similar to the way that we created maps. You use the make keyword. So I'll call this an int chan. It's going to be a channel of ints. And it is created by saying make chan int. And all that says is I'm creating a channel, a place to send information, which will be received in one or more places in my program. And that channel can only hold ints. That's all that it can hold. So what do I do with that? Well, it's pretty straightforward. Let's create another function, and I'll do it above the main function. And that's going to be called func calculate value. And it's going to take an argument of int chan, and it's a type channel of int, and it doesn't return anything. And what does this do? Well, in here I want to generate a random number, and then I want to do something with that random number. And just for fun, I'm going to create my random number function over here in my helpers function. So let's create a random number, and it's not as easy as you might think. We can do it like this. We could say func random number that takes an argument. We want to create a random number from a pool of some size, and that will be an int, and it will return the random number we calculate. So what do? We can say, first of all, we could say value is assigned, and we're going to call a built-in package, okay? We're going to call a built-in package from the Go language, and it is called math. So we will use rand, and we're going to choose the correct package here. We want rand, and the function we want is intn. There it is, math random. And it's going to take an argument, and the argument it has to take is how big is the pool. So that will be n, what we passed as a parameter. So now we've created a random number, and we just want to return that. That's all that we want to do. So we can say return value. Okay, so apparently we've created a random number. Let's go back to our main program, and let's get that random number in our calculate function. So random number, which is just a variable name, is assigned the value of, and I want to call random number, helpers random number, and I want to call it from some pool. Now I could put 10 in here if I want to, but I'm going to use a constant. Const, and I'll call it numPool, and I'll make it equal to 10. And then I'll just use that constant down here, just because I can. So that would be numPool. And we want to return that. Do we want to return it? No, we want to use our channel, because what we've passed it is a channel. So I'm going to now pass that random number that I've just generated into my channel. So, and I do that using a very simple syntax. Int chan, the channel name, and I'm going to pass it random number. Okay. So now down here, I've created in my main function, I've created that main channel, and I want to close it once this program or this function is finished executing. Now, we're in our main function, so technically I don't have to close it because the program will exit as soon as I'm done. But it's good to get in the habit of doing this: defer, close, and my intchan. Now that defer is a word we haven't seen yet, and it's one you're going to be using regularly in our programming as we go through this course. And all defer says is, whatever comes after this keyword defer, execute that as soon as the current function is done. Now, that becomes useful because in situations where, for example, I open a file or I open a connection to the database, I don't want to leave those things open forever, because every time you open a file on your file system, you're using one of a limited number of files that you can have open at the same time. And if you leave them all open, every time you create a file or open a file for reading, for example, eventually you're going to run out of handles for the files. So you want to close them after you open them. And the same is true of database connections. You can have a limited number of database connections open at a given time. And when you run out, bad things happen. And closing them after the function is finished, after you're finished using that function, is just good practice. In fact, it's critical. You have to do it. So here, I don't want to have, I can have a limited number of channels open. It's a big number, but if the program runs for 7 months or 12 years or whatever, eventually you're going to run out of them. So I close them when I'm done with it. And here, I'm just going to do that because it's good practice. Now, we are going to call our calculate values, but I'm going to do it in a way that you haven't seen yet. And I'm going to do it by sending it off as a concurrent operation. I'm going to do it by running this routine in its own Go routine so it runs. And the nice thing about this is Go routines run at the same time. So if I need to do 1,000 things, I don't have to do them one at a time. I can fire off 1,000 Go routines, all of which run at the same time. 1,000 is a big number, but you get the idea. And you do that simply by saying Go in front of the call to the function that you want to call. And that turns it into a Go routine. And I'm going to now call calculate value, and I'm going to pass it my channel, intchan. There, I have done that. And now I need to listen for the response to that channel. So up here, I passed a value into the channel. Down here, I want to get a value from the channel. And I do that. It's a really straightforward syntax. I'm going to say my number, whatever it is, I'll just call it num, is assigned the value of whatever comes from intchan. And then I'll print it out. Log.println and num. All right, so that should work. Now let's see what happens when we run this. I'm going to open my terminal window, and I'm going to clear the screen, and I'm going to just run the program. Go run main.go. I got 1 out of my pool of 10. Let's run it again. Go run main go. I got 1. Go run main go. I got 1. This doesn't seem terribly random, and in fact, it's not. And it's not for a very simple reason. It would be random if this program was called, it would be pseudo-random if the program wasn't exiting every time it was called. But in my helpers file, if I roll over int n, you actually see a little comment here. Seeding with the same value results in the same random sequence each run. For different numbers, seed with the different values, such as time.now.unixnano, which yields a constantly changing number. Aha, that's all we have to do to get a random number here. So I need to seed it. And I seed that by saying rand.seed. And what I want to do is exactly what they told me. Inside of those parameters, I'll go with time.now, which is the current time. Oops. Now, which is the current time, and then I want to get the Unix Nano. And that gives me a different number every time I run this. So if we go back to our main program, and we clear the screen, and we run it again, this time I got 2, and I run it again, and this time I got 3, and this time I get 6. So now it is more random. So what it's returning is a random number between 0 and my num pool. So if I make this num pool 1,000, and clear the screen and run it again. This time I got 50. This time I got 412, 730. But the important thing here is not the fact that we're getting random numbers, it's where we're getting that value from. So let's go through this. I have a main package. I have my main function. That runs first. Actually, it declares this constant first, but this runs first. And then I create a channel that can only hold ints. If I try to pass a string or a float or a date or something else in there, it's not going to work. You can't even compile the program. It can only take ints. Then I say, when I'm finished running, close this channel, which is good practice. Not necessary in the main function, but I'm going to do it anyway. And in later situations where we use this main function to initialize channels, and then the main function continues to run for a long time, that's definitely critical. So do that. Get in a good habit of closing things that need to be closed. And we'll be going through a number of things that need to be closed. So I create the channel, I defer the close, and then I say, fire off a new Go routine, run this by itself in its own routine, and hand it the int channel. Great. So this fires off up here, this as a Go routine, and that takes a channel as an argument, and I generate a random number, and then I just say, push that back into the channel you've just given me. Down here, I'm listening for that channel, and when I get a value from it, it's passed into this variable num, and then I just print it out. So that's just a really useful way of passing information from one package to another package, or one part of your program to another part of your program. Incredibly powerful and very, very useful when you have more than one package in your program, which we're going to have. So those are channels, and we'll be using them regularly as time goes on.